All right, welcome back. LightGBM. But before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Okay, so we're going to get started with LightGBM, Microsoft's efficient gradient boosting revolution. Throughout the landscape of gradient boosting algorithms, where XGBoost had established dominance, Microsoft Research introduced LightGBM. It's a big promise, right? Deliver superior speed and memory efficiency without sacrificing accuracy. Standing for Light Gradient Boosting Machine, this algorithm represents the next evolution in ensemble learning, incorporating innovative optimizations that address the computational bottlenecks that constrain traditional gradient boosting approaches. LightGBM emerged from Microsoft's recognition that while gradient boost delivers exceptional accuracy, its computational requirements often limit practical applications on large data sets. By introducing novel techniques like gradient-based one-size sampling and exclusive feature bundling, LightGBM achieves dramatic efficiency improvements while maintaining the prediction quality that makes ensemble methods so valuable. So, innovations in ensemble learning. Excuse me. So LightGBM's core innovation lies in its sophisticated approach to computational efficiency. So traditional gradient boosting algorithms process every data point and feature during each iteration, creating computational overhead that scales poorly with data set size. So LightGBM introduces intelligent sampling and bundling strategies that maintain algorithmic effectiveness while dramatically reducing computational requirements. All right, so here's a couple of pieces that revolve around this. Let me see. Do I have it here? All right, GOSS. GOSS, gradient-based one-sided sampling, right? This is a fundamental insight about gradient boosting behavior. During training, data points with larger gradients contribute more significantly to learning than those with smaller gradients. GOSS leverages this observation by focusing computational resources on high gradient samples while strategically downsampling low gradient examples, maintaining learning effectiveness while reducing processing overhead. Let's see. Actually, let me see if it's... No. Okay, that's okay. All right, and then EFB. All right. Let's see. Okay. Oh, let's see if we can get this. There's no specific article. That's okay. But okay, so EFB, exclusive feature bundling. So this addresses the curse of dimensionality that affects high dimensional data sets. Real world data sets contain sparse features that rarely take non-zero values simultaneously. EFB identifies these mutually exclusive features and bundles them into single feature representations, reducing the effective dimensionality without losing information content. So these optimizations work synergistically to deliver LightGBM's performance advantages. The algorithm achieves faster training times, reduced memory consumption, and improves scalability while producing models that match or exceed traditional gradient boosting accuracy. And this is across it's across diverse problem domains. So SageMaker integration. How does this integrate with AWS? All right. So LightGBM's efficiency makes it particularly valuable for scenarios where traditional gradient boosting becomes computationally prohibitive. So financial services organizations can use it to speed up real-time fraud detection systems that need to process thousands of transactions per second while maintaining high accuracy rates. Think of like an e-commerce platform. This might use LightGBM for a large-scale recommendation engine where the algorithm must rank thousands of products across millions of users within strict latency constraints. The algorithm's ranking capabilities combined with its efficiency enable sophisticated personalization systems that operate at internet scale. Then you have a marketing analytics team. They might use LightGBM for a customer churn prediction and a lifetime value model across massive customer databases. So the algorithm has the ability to handle high dimensional features and then efficiently make it ideal for scenarios involving complex customer behavior data with numerous interaction features. And finally, a manufacturing organization might use it to predict maintenance systems where sensor data for thousands of machines have to be processed continuously to predict equipment failures before they occur. So the algorithm's distributed training capabilities enable real-time model updates as new sensor data becomes available. So you can see some of this here. Excuse me. So let's go into the console. All right. Right. goes. So SageMaker AI. Let's say training. All right, so we're here under SageMaker AI when the training jobs. We're going to create a training job. So this interface will help you get there, right? And so we can type in a general name. Let's say LightGBM test. All right, and then we're going to have, you want to make sure you have consistent naming conventions. Next, you have the IAM role that you want to use. You can create a new one. You can enter custom one from the ARN. You can use existing ones. We're just going to use the data zone one that already exists here. Use the built-in algorithm. Choose the algorithm, and it should be why am I not seeing it? K nearest image. Why am I not seeing it? Huh. Algorithm container. Let me see. Maybe they put it. There's no resources there. Okay. SageMaker built-in. K nearest factorization. I'm not seeing it. And I'm sure neither are you. This is very interesting. Very interesting. All right. Oh, so this is fun. I'm not sure why this isn't here. Let's go to learn more, see if there's anything here. Um, we've already seen this. Yeah, this is on, see the built-in algorithms. LightGBM is here. Huh, there's SageMaker AI, single instance and multi-instance CPU. It's memory bound. Yeah, that's instructions on how to create. See, oh, the notebook instances. Okay, that makes more sense. All right, let's go back out of here. Notebooks. Okay. So my suspicions, you have to create the notebook instance, and then you'd have to create LightGBM. All right, we're not going to do that because this is going to take a long time to get that up and running. But basically, all right, so you'd want to get the instance type, right? One of these instances, make sure it can handle it, platform, data zone, encryption, what networks you're going to use. We have the default. Any Git repos you want to have to pull in code for any containerization. Once you get that instance created, then you would be able to import it. So that is crazy because it's not on the list. That's unfortunate. Okay, we're going to exit out of that. That is very unfortunate. Yeah. All right. I hate to say it, but okay. So let's go forward. Apologize for that. So you see SageMaker AI, create a Sage domain and then setup. And then let's see. No, that's not going to be it. Okay, we'll go to cost. Okay, so LightGBM's resource characteristics enable strategic optimization for performance and cost, right? So the algorithm's memory-bound nature suggests prioritizing memory optimized instances over compute optimized alternatives. So even when the compute optimized instances appear more cost-effective per CPU core, this is what you can use, right? So distributed training is valuable, especially when the data set exceeds a single instance memory capacity, or if training time requirements demand additional parallel processing. And this is why LightGBM's distributed implementation can scale efficiently across multiple instances while maintaining algorithmic consistency. So the cost optimization involves balancing the instance type, which we alluded to, with training duration and accuracy requirements, right? So powerful instances can complete training faster, but can cost more per hour, while smaller instances can require longer training, but offer lower hourly rates. So there's an optimal choice that depends on your specific data set characteristics and time constraints. So consider spot instances for non-urgent training to achieve the cost savings. And LightGBM's training checkpoint capabilities can enable recovery from spot instances and interruptions and make this a cost optimization strategy for any production scenario. And to wrap up, excuse me. So LightGBM's efficiency advantage extends beyond training to inference deployment, where the algorithms optimize model structure and it can enable fast prediction generation with modest computational requirements. So this efficiency will translate to cost-effective model hosting and reduce latency for real-time applications. So you can deploy a trained model using SageMaker's endpoint for infrastructure for real-time inference or batch transformation jobs for offline prediction scenarios. So the excuse me, the LightGBM models can require minimal inference resources and it can enable deployment on smaller instances that reduce hosting costs while maintaining acceptable performance. So you can implement the monitoring for both the training and the inference workloads. You can track key performance indicators like prediction latency, throughput, accuracy metrics, and resource utilization. And then the monitoring can help you be a little more proactive to identifying performance degradation, and you can optimize different opportunities, right? So consider implementing retraining pipelines to use LightGBM's training efficiency to maintain model freshness as new data becomes available. And then that algorithm's fast training capabilities can make frequent retraining economically viable for maintaining prediction accuracy in dynamic environments. So remember, LightGBM is the successful evolution of gradient boosting technologies for modern big data, right? You can address computational bottlenecks that can limit traditional approaches, and you can maintain prediction accuracy. So it'll help any organization deploy sophisticated ensemble learning at pretty high scale previously considered impractical. So it's a combination of algorithmic innovation and engineering optimization to make LightGBM a great tool for any organization that wants to get maximum value for a large structured data and maintain operational efficiency and cost effectiveness. Well, I apologize for that, but for that disruption. Regardless, thank you for joining me. Next up, we'll be going over to sec. But before that we go, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.